Okay, permutations versus combinations. Today, you will learn the difference between these two and how you use them to count. Of course you can count, but when you are faced with choices, like for instance, I'm going to pick from A, B, and C. How many different choices are there? Well, it depends. If the order doesn't matter and you pick A, B, and C, then there's only one choice. You pick A, B, and C and you're done. You've chosen it. But if you pick A, B, and C and you can rearrange them and the order matters, then do you get B, C, A would be different than A, B, C, would be different than C, A, B. Okay? So the order that you do things in either matters or it doesn't. In the real world, it depends. On your password, does the order matter? Yeah. On picking 3 friends to go with you to a movie, does the order matter? No. When you sit down in the chairs at the theater, does the order matter? There are different ways in which you can arrange yourself. And so there's a bunch of different ways. If you have 5 friends, they're all going to sit in the seats. A bunch of different ways you could arrange it, right? That's order matters again. If you say, I want 2 people to stay after class and help me, pick up the floor or whatever, does the order matter? So if I pick you 2, but it doesn't matter if I pick you first and second and vice versa. Okay, so order sometimes matters and sometimes it doesn't. All right, here's an important formula. Write this down. Formula for 3 things to choose from. You're not looking at the board. 3 things to choose from. P2, that means P for order matters. P stands for permutation. Now, I'm going to say it in a dumb way that should help burn it into your brain. Order patterns. And I'm going to say it that way every time just to annoy you. And it'll eventually make sure that there's no chance that you will connect P with order matters. Okay? Because if you start doing combinations where you should be doing permutations, you'll get these all messed up and all wrong, and you'll fail the test. But if you can keep those 2 things straight, you got half the battle. All right? So 3P2 stands for a permutation, and order will matter, versus if you do the formula over here, 3C2, that means combination, and the order will not matter. Now, there's an actual formula for figuring out the answer. Let me give you this example. I have 3 things on this table. I'm sure that was incredibly loud. I told them people are probably running for the volume. Anyway, this, and this, and this, okay, which you can't see at home, we have a box full of spiders and a roll of incendiary paper and a box of Kleenex. Innocent box of Kleenex. All right. Now we're going to rearrange these things, okay, and to different orders because the order matters. Okay. So on this first one, 3P2, there you get there's 3 things here, okay, and P2 means I'm going to take care of the order mattering and sets of 2. So out of these 3 things, I'm picking 2 of them. I'm picking these 2. Yay, I picked them. Now, there's that, which is Kleenex and box of spiders. I'm going to rearrange that now. Box of spiders and Kleenex. That counts as 2 different things. You get that? Because if the order matters, you want to keep track of how many different things there are. So I picked out a set, and then I rearranged it. So far I have 2. Now I'm going to go back, pick out these 2. Okay? 3rd way. And now I'm going to rearrange them. 4th way. Now the things that I haven't done yet. Those 2. And then that way. You get I'm a total of 6? All right. Then there are 6 for this formula right here. Now I'm going to show you how you could have calculated it without having to actually grab the items and rearrange them and everything. There's a fancy formula, and it goes like this. 3 factorial over 3 minus 2 factorial. Now, I know that's the same thing as 1. 3 minus 2 is 1. But it's not always going to be 1. It's always going to be this one minus this one. Okay? Then, this other formula for combinations is very similar. It's in fact, it's identical except for one thing. On the bottom where it says 3 minus 2 factorial, that's still the same. But you throw in one extra one of these. Okay, so that's a 2 factorial. You throw an extra 2 factorial in to the combinations formula. Now, some of you might not recognize the factorial, the little exclamation mark deal. How many of you actually have seen that before? Okay, 4 or 5 of you have seen that before. What that means is simply this. 3 factorial means, here, I'm going to write it up here. 3 times 2 times 1. What do you think 4 factorial means? 4 times 3 times 2 times 1. Get the idea? With 7 factorial, go 7 times 6 times 5 times 4 times 3 times 2 times 1. So you obviously they get a little annoying when it's like 28 factorial, but there's a button for that. There's an app for that on your calculator. Everybody grab your graphing calculator. If you don't have one, borrow one from me. I'll pause for a second while we do that. All right, so we are on to example 2. I paused the recording a while back, and I am now getting into the heavy-duty stuff. On example 2, we are doing blanks again, and we're going to multiply these choices, having them try this problem. Pausing now. On that one, you have, can anybody make an argument that it should be 3 because there's Greg, Sam, and Tyler? No, because the girls could just as equally win. So even though they're in 2 different groups, we have a total of 5. 5. Now, why are they divided up? You'll see in a moment. They're going to force it to have a girl needs to finish first and third. That's why they divided it up. Right now, we could have just said there were 5 people and never even divided them up. 5 times 4 times 3, true or false? True. Why can't you do 5 times 5 times 5? Somebody's already been picked. Then you can't pick them again. Very good. All right. So, how many different ways can the 5 racers place if a girl needs to finish first and third? Okay, make 3 blanks again. Now, a lot of people think you have to do these in order. You do not. You should take the blank that has special needs and do it first. And in this case, there's 2 of these blanks, first and third. These ones are special. We should do them first. So what are the rules for those spots? A girl has to be there. So how many choices do I have for the first spot? 2 choices, because there's 2 girls. Okay. And then the last spot. There's 2 girls, so I put 2 there, right? Now I already used the choice, so I don't have 2 choices anymore. I only got 1, so times 1. And now, how about that middle spot? Could a girl win the middle spot? No, because we've already used both girls. They're already in the first and the third spot. So it's only boys. There's 3 of them. There we go. 2 times 3 times 1. You see how I started with the ones that had special needs? All right. What is the probability that a boy finishes second? Well, here's first, second, and third. Start with the spot that has special needs. Figure it out, and then figure out the other 2, and then multiply your choice. Why don't you just see if what you think it should be like. I think it should be 5 times 2 times 3 or whatever. Compare with the kid next to you. I'll pause for a second while you give that a try. Okay, so here's what you should have thought for this one. Okay, boy finished the second. The spot that's important is the second spot. How many choices there? There's 3 boys, so I'll put a 3. Now how about the first place spot? Well, everybody could finish there, right? So I put 5. True or false? False, because I used up one of the choices, so therefore 4. Could be a boy or a girl though, right? Didn't say anything, didn't give me any limits on the first spot or the third spot. So that's a 4. Would have been a 5, but we already used a choice. Now, what's the next one? 3. Got to be 1 less than this, right? Because we just used it up another choice, so here we go. 4 times 3 times 3. Raise your hand if you had that one right. All right, not as many. Yes, sir. Okay, oh, you make a good point. I haven't got a probability yet. All I've got so far is a total number of ways that a boy could finish second. Thank you. All right. Now, to make it a probability, of course, we have to divide it, what you want over what's possible. So this is what I want, divided by what was possible. These are all the different ways. That goes on the bottom. Now, I'm going to make it 5 times 4 times 3, and I want you to see something cool that happens. You get this 4, cancels this 4. Get this 3, cancels another 3 down here. So you get that the answer is 3/5. So you wouldn't have to actually multiply them all the way out. You could just cancel them. All right. All right. Moving on. Example 3, and I'm going to give you a hint. In your class, there's a lot of people who are really good thinkers. So I'm going to say you might be able to figure out number 3, but I couldn't. I now know the answer, and I can show you now. But it is not easy the first time you do it because it's given. So it makes the denominator something complicated, but I couldn't figure out what. And when somebody showed me, gave me a hint, it was like, oh, that's obvious now. Okay. Let's do number 1 and 2. Those are both easily doable. How about you try them without me? I would recommend you use blanks, even though you could use P's and C's. Blanks are probably easiest for this type of problem. I'm going to pause for a second while you try number 1 and 2 and compare with the people next to you. Okay, here's how number 1 should have gone. What's the special needs spot? Well, there really isn't one, so we can just do it in order. How many choices do I have for first place then? 8, because it's you and 7 other swimmers. If you fell into that trap and you thought it was 7, I totally get that, but 8 times 7 times 6, because we keep picking a new person out and then we have less choices. Raise your hand if you think you get that. You understand that. Okay, good. On to the next one. Number 2, how many ways can the swimmers place if you finish? Ooh, special needs on second place. First, second, third. That spot's special. I'm going to pick. How many choices do I have? If you are finishing in second place, how many choices do I have? 1. And therefore, less choices for first place. It's not 8 anymore. It's 7. And then how many choices left for this last spot? There you go. 7 times 1 times 6. Raise your hand if you had that one right. Okay, good. We did not do a probability yet. All we've done is how many total are there. Well, you do a probability, of course. You want totals like that, but you divide them. So let's try to figure out if it's as simple as the top divided by the bottom number. It's not. So, what's the probability that you finish in third place? Ooh, I bet you can write that part. Everybody do the top part. You finish in third place. That's what you want. You know how the 3 blanks should go? If you finish in third place. That's easy. I could do that. I know you can too. Everybody finish that part. Now here's the given that messed me up. I knew it was saying given you finish in the top 3. So I knew that it wasn't just all the possibilities. See, a lot of people think you just put the 8, 7, and 6 on the bottom. You don't, because that would be all the possible things. We've narrowed it down. You are in the top 3, so that's not going to be all the choices. It's going to be less than that. So it can't be 8, 7, and 6. On the top, I hope you got this. If third place is you, then it's a 1 there, only one choice. 7 and 6 go there. 7 times 6 times 1. Raise your hand if you had that part right. Good. So who can figure out this bottom part? I'm going to see if anybody can get it without me. I don't want you to just give me a number. You'd have to tell me what did you multiply to get that bottom number, because that's the tough one. If you need a hint, I will give you a hint that will make probably half of you be able to figure it out. But maybe somebody can do it without my help. Given you finish in the top 3. Yes? Okay, but I don't want to go a completely different route on this. Maybe we will at the end. Okay? But just, what could I do on the bottom here? There's a way to do this, but it's not 8, 7, and 6. Yes? Wait, 7 times 6 times 1 plus, keep going, Oh, you got it. Nice job. What in the heck is she doing? What she did is you either finish third, or, remember or means add, or you finish second, or you finish first. And or means add. So yeah, that's how you do it. Very nice. I'm impressed. Nobody has gotten that all day. Would it be number one out of top? Oh yeah, sure. Easy to say so now. Did you really? All right. Good. All right. There's always that kid who's afterwards and could actually be honest, being honest, but once it's been shown on the board, it seems so obvious. Yes, sir. All right, hold on. Let's get the answer for this, and then see if your easy way answer comes out the same. Okay. So this is 42, 42, and 42. So that adds up to 4 times 3 is 126 on the bottom, and it's 42 on the top. So 42 out of 126, or I think I know your easy way, 42 over 42 times 3. See what I'm saying? You know, 42, there's 3 42s down there, so I said 42 times 3, which means the 42s could cancel, and the answer would be 1/3. All right, so now what was your fast way? Now that you know the answer, it'll be easy to make sure you're right. Go ahead. Is that the way you did it? All right. So since there were only 3 ways that could happen, you're either first or second or third, then there's only 1 out of 3 ways. I like it. That's a really good way to do it. Now, the vast majority of the time, you're not going to be able to do that. I hope you get this whole blank thing, because that was a cool way to do it, but it's not something I can replicate for the next problem. All right. This part gets pretty easy. It's going to be just like the license plates things, except the zip codes. You use blanks. You don't have to do it. So let's do your homework now. Everybody find your homework. And because in the other class, if it had been this much time in the other class, I probably wouldn't have given this. But I did it for first hour, so I'm going to keep doing it. Only evens today. So problem number 1 is a whole bunch. A, B, C, D, E. You can skip problem 1 and go to problem 2. Yes, sir. Yes, sir. All right. Evens only on the homework tonight. And that is all I have for the video for today.